All right, so the other day in class, we spent some time practicing division of polynomials using long division. So there is something called synthetic division that's a little bit of a shortcut that can only be used in certain situations. So polynomial division with long division can be used dividing any polynomials. But the shortcut that we're going to learn, the synthetic division, can only be used in certain situations. So really quick, write down that learning target. We're going to divide polynomials using synthetic division. So the first thing that you need to know about synthetic division is that it's a process whereby, which by the way is a funny word, I thought so, the quotient and the remainder can be determined when a polynomial function f is divided by x minus c. So we're still dividing two polynomials. So our dividend, the polynomial that we're dividing up, can be any polynomial. However, the divisor, the polynomial where we're dividing by, has to be in the form x minus c. So there's a couple things that have to be true about that. So you'll notice in x minus c, the leading coefficient of the divisor must be 1. So you'll notice in this x minus c over here, my leading coefficient in front of the x is a 1. Also, the degree of the divisor must also be 1. So the degree, so it's a linear function, so you can't have like x squared plus 3x minus 4 as your divisor. So that's where you kind of have the restrictions on when we're using synthetic division instead of long division. So if we have two polynomials that we're dividing and the divisor meets those criteria, so in this case x plus 2, then we have a coefficient of the divisor, which is 1. The leading coefficient of the divisor is 1, and the degree of the divisor is also 1. So we can use synthetic division in this situation. All right, our first step for synthetic division. We first need to figure out if we have x plus 2 as our divisor. So remember, whenever we're dividing by something, that's like a factor. And when we're talking about polynomials, we're talking about the x-intercepts. So I want to know if x plus 2 is what I'm dividing by, that would mean that I would have an x-intercept of -2 on the graph. So I'm going to use -2 to set it up. Okay. And then we are going to use just the coefficients of the dividend. So the dividend, remember, is the polynomial that we're dividing into. And this is our divisor. So we take that -2 from the divisor, so always the opposite, put that on the outside of this little half rectangle here. And then on the inside, I'm going to put just the coefficients of the dividend. So that would be 6, 10, 1, and 8. All right. And remember, this is just a shortcut. So the process I go through, the first thing I'm going to do is I'm going to bring this 6 down underneath. Okay, so the first coefficient always just comes straight down. Then I'm going to take my -2 and multiply it by that 6. I'm going to do. So my -2 times 6. So times by -2. And I get -12, and that goes here. Then I'm going to take the 10 and the -12 that are now lined up, and I'm going to add those together. So 10 plus -12 is -2. And repeat the process. I'm going to take the negative 2 that I got from the divisor and multiply it by that new negative 2 that I just got. So negative 2 times negative 2, and I get 4. And that goes there. Now I have my 1 and my 4 that are lined up, so I'm going to add those together. 1 plus 4 is going to be 5. Keep repeating that same process. I'm going to take my negative 2 that I got from the divisor and multiply it by that 5 that I just got. So 5 times negative 2, and that gives me negative 10. The 8 and the negative 10 are now lined up, so I add those together, and I get negative 2. All right, so what these numbers at the bottom mean, these are now your coefficients of your quotient, and the last number is always your remainder. So since I started with a cubic polynomial as my dividend and I was dividing it by a linear polynomial, so I have an x cubed divided by an x, which is just going to be x squared. So my quotient now is going to be a quadratic polynomial, with a polynomial with a degree of 2. So your quotient, your answer, is always going to be 1 less degree than the degree of the dividend. That's because we're dividing by an x in the divisor. So my new answer, I'm going to take that 6, and I know the degree of my polynomial is going to be x squared, so 6x squared minus 2x plus 5. Okay, that comes from these 3 numbers here, plus my remainder, which is negative 2, over the divisor, which was x plus 2. So that's going to be my answer. Okay. Let's go ahead and try another one. Okay. So we have 7x cubed minus 17x squared minus 15x plus 9, and we're dividing that by x minus 3. So double checking to make sure, so this is our dividend, and our divisor has both a leading coefficient of 1 and it's the highest degree of 1. So we can use synthetic division. So since my divisor is x minus 3, that 0, that x-intercept, is going to be positive 3. So that's what I'm going to use for my synthetic division. Okay, putting the coefficients from my dividend in order. So 7, negative 17, negative 15, and 9. All right, let's start the process. Always bring down that first number, that first coefficient, which is just 7. Now we're going to take my 3, which came from the divisor, times this 7. So take the 7 and multiply it times that divisor, and I'm going to get 21. Negative 17 is now lined up with 21, so I'm going to add those together. So I now get negative 17 plus 21, which is 4. Okay. So now I have that 4. I'm going to multiply the 4 times the number I got from the divisor, which is 3. So 4 times that 3 up top. 4 times 3 is 12. Negative 15 is now lined up with 12, so I add those together. Negative 15 plus 12 is negative 3. Take that negative 3 that we just found, multiply it by the 3 from the divisor, and I get negative 9. Add 9 plus negative 9, and I get 0. So my remainder is going to be 0. So my polynomial I take from those 3 numbers. So I started with a cubic polynomial, was my dividend. Since I'm dividing by an x to the first, that means my new degree is going to be 1 less than the degree I started with. So my answer is going to be an x squared, would be the highest degree. So 7x squared plus 4x minus 3, and I have a remainder of 0, so I can just leave it like that. Okay. So when I take 7x cubed minus 17x squared minus 15x plus 9 and divide it by x minus 3, I get 7x squared plus 4x minus 3. All right, one thing that I'm going to quickly introduce to you as a reason that we use synthetic division, and we're going to really get into some stuff where we use synthetic division, but just as a quick preview, we can use synthetic division to determine whether x minus c is a factor of a given polynomial. So if you go back to like elementary school math, and if you were asked to determine if a number is a factor of another number. Okay? So, for example, if I said, is 12 a factor of 3,659? Okay. So is 12 a factor of 3,659? Think for a second, how would you determine if 12 is a factor of that big number? All right, so hopefully thinking back to your elementary school-ish days, and and if we want to know if 12 is a factor of 3,659, then what we're going to need to do is 12 will need to go into 3,659 evenly. In other words, I should be able to take 3,659 and divide it by 12 and get a number with no remainder. So in this case, 12 is not a factor of 3,659 because when I divide 3,659 by 12, I get 304 with a remainder. Okay, so it would not be a factor. We can do the same thing with polynomials and using long division or synthetic division. In this case, we're going to use synthetic division. So if I take two polynomials and divide them, the remainder would have to be 0. So I would divide them and get a remainder of 0, then it is a factor. If I divide them and if I get a remainder of something other than 0, then it's not going to be a factor, just like with regular numbers. So let's see if we can determine whether x minus 3 is a factor of 2x to the 5th minus 18x cubed plus x minus 9. Okay, so I want to divide these. Since my divisor, the number I'm going to be dividing by, has a leading coefficient of 1 and is a linear polynomial, I can use synthetic division to figure this out. Okay, so I'm going to set this up. So 3 comes from my divisor. Now notice I go from, in my dividend, I start with an x to the 5th and skip to x cubed. So we're going to fill in zeros in place of the missing x to the 4th and x squared. So 2, 0, 0, negative 18, 1, and negative 9. Now in synthetic division, need to be sure to put those zeros in, otherwise it's not going to work. So if you have any missing terms, make sure you fill zeros in for those coefficients. All right, so I'm going to bring my 2 down. 3 times 2 is 6. Add those together and get 6. 3 times 6 is 18. Okay. Add those together and get 18. Okay. 3 times 18, let's see, 54. So 54 plus negative 18 is going to be 36. Multiply that times 3. 36 times 3, 108. Add those together to get 109. Multiply 3 times 109, which is going to be, hold on, 327. Add those together, and I get a remainder of 318, which is obviously not a remainder of 0. So when I divide 2x to the 5th minus 18x cubed plus x minus 9, and I divide that by x minus 3, I do not get a remainder of 0. So x minus 3 is not a factor of 2x to the 5th minus 18x cubed plus x minus 9. Okay? So simple enough. If you want to figure out something's a factor, you just divide it, see if you have a remainder. Same as you would have done when you're just dividing two numbers. All right, so here I'm going to give you some optional practice. This time it's not required. So the exercises in Interact Math, I've listed them here. These are the exercises that match the problems that we just worked on in this PowerPoint. So do some of them or all of them if you feel like you need a little extra practice. So that's kind of up to you. You can do a couple. Once you start to feel comfortable, you can stop, or you can do them all just to make sure you feel really comfortable with it. So that's optional practice for you. And we will talk about it and review some of it a little bit in class next time.